In previous videos, I've been talking a lot about semantic versioning, but I haven't been getting into the details. In this video, I'll cover the concepts behind semantic versioning and how it's used in practice. As you've been looking at more package.json files and seeing more version numbers, you might be wondering what the structure means and what these extra symbols are. These version numbers are structured like this because they're using semantic versioning, or semver, which is a standard that a lot of projects use for communicating what kinds of changes are in this release. And the reason that it's important to communicate what kinds of changes are in a release is because sometimes those changes will break the code that depends on this package. So proper use of semantic versioning is a good way of communicating with the users of your package to let them know the level of effort it's going to take for them to update to the latest version. So now let's take a look at the meaning behind these numbers. Generally, a project that's going to be shared with others should start at 1.0.0. Now, this hasn't always been followed by packages in NPM, so you'll still find lots that start with 0. But what it means to start with 0 is that your package isn't yet stable for the initial release. So when it's ready for people to depend on it, and to depend on the functionality being consistently numbered, you'll want to start with 1.0.0. Now, if you make a change that's not going to break anything and doesn't add any new features, it's just something like a minor bug fix, then you'll add it in what's called a patch release. And to do that, you just increment the last number, the third number. If you add a new feature, like a function to the API, which doesn't break anything but just adds functionality, then that's a minor release. So you increment the middle number. And finally, if you make a change that is going to break things, it's a change to the API that's not backward compatible, then you have a new major release. So that's how you use semantic versioning as the publisher of a package. The way that you'll use semantic versioning as the user of a package is to specify which kinds of updates you want to accept. So you may decide that you only want to accept patch updates. You don't want any changes to the API to be included in the updates that you're bringing down. And this can be indicated in your package.json file in a few different ways, including having an X in the place of the patch number or having a tilde in front of the exact number. Or you may choose to download new features, but not anything that's backwards incompatible. So there are a few ways of indicating this as well, including having an X in the place of the minor version number, or having a hat or a caret symbol in front of the exact version. And there are lots of more specific ways that you can break down what different updates you'll accept. So let's take a look at this in practice with the module that we created in the video about publishing packages to NPM. And let's assume that we have a bug in it. This should be read RED and not read READ. And you'll see it's not working for the user of this package. It's giving them undefined instead of printing the message we want it to. So let's go fix this bug. We're just going to change that back to read RED, and then use npm version patch to increment our version number, just the patch part of our version number. And then npm publish, and when I switch back to the consumer and download that update and run it again, you'll see that the bug is fixed, I get the message. Now let's try adding some functionality. For this, I'm going to make the color that the message prints out in configurable. And you'll notice that this code takes a parameter called color, and if it's not set, it will set it to red, which was our existing value. So this change is backwards compatible because anybody who is running the function right now without passing in a parameter will get the same value back that they would have before. So because it's backwards compatible, we can use npm version minor. And when the consumer gets the updates for our package, their code still works as expected because there's no backward incompatible changes. But if they wanted to, they could figure out what features we had added in this minor release and go into their code and make the changes so that they can make use of these new features. So now let's add a change that is backwards incompatible. Let's make the message that's displayed configurable and not give it a default. This means that any consumers of our code who are using this method are going to get an error when they update our package. So because this is not backwards compatible, we're going to use npm version major to bump the major version. So now if my consumer installs it as they have been without specifying a range, this code is going to break. So to fix this, the consumer should specify a version range that they'll accept. In this case, I'm going to use the @ and then 1.x to say that I want anything that's a minor version release. And I'm just demonstrating this as part of the command, but it's usually specified in package.json. And now that I'm back to version 1.1, something in the same major version as what I've been working with before, my code works again. So that's how npm does versioning. Patch releases are used for bug fixing. Minor releases are for features which are backwards compatible. And major releases are for when you're changing your API so that it's no longer backwards compatible with previous versions. As I mentioned before, there's lots of ways to specify more complex ranges of versions, so check out the npm docs for those. And check out our channel for more videos on working with npm.